How you doing? Okay, so what I'm going to do is I'm going to run through Abby's flowchart, and I'm going to show you how to do this set of 4 using flowchart A. So this is a straightforward one. First of all, I have my spot place. And what I'm going to do is I'm going to come over to the sink. Thank you. And I'm going to make sure that I spray this nice and clean with the deionized water. Okay? Really give it a good clean. You don't need to worry about drying it, because it's deionized water. It has no reaction with anything. Might just want to wave it out though. Then I want you to notice how I'm lining this up. Each test tube has its own little well here. There we go, that's better. So each test tube is lined up, each little dropper is lined up there, and my test tubes are labeled C1, C2, and I'm sorry this is in reverse for you, but it makes sense to me, C3 and C4. And so I'd make sure that I keep that set up like that, so that down each of these columns is each of those unknown chemicals. So Abby's first test is add CaCl2, her second test is add MgSO4, and her third test is add magnesium metal. Okay? So what I'm going to do is I'm going to fill up each of these rows with chemicals, because I'm going to need each one of these. I want to be careful about where I put my tops. I'm going to use my eyedropper, and I'm going to place a little drop of solution in there. You only really need a couple of drops. You don't need a whole lot. I'm going to make sure that my test tubes stay well away from each other, or my eyedroppers I should say, because my eyedroppers are not capped, and therefore may drop some of the solutions all over the place, and I don't want to cross-contaminate. I may also want to fill up more than one well. I know where all these chemicals are going, and so therefore I'm just going to fill up each of these wells in turn all the way down. Now, if you see how much of the chemical I've actually used to do these 3 tests, I've not used very much. I still have lots in there. All right, I've not even used a third of it. So I have plenty to make sure that I get all of my tests done with extra to spare in case for some reason my testing goes wrong. I need to go back and check my results. This is where we need some music and some fast forwarding. Yeah, you're in charge of fast forwarding. So I want to also watch out for my fingers, because hydrochloric acid will, we use fairly high concentrations of HCl in Qual so that you get a good reaction with it. There was one year where somebody was not looking where they were going on their way to the cleanup station, and they had an open container of HCl, and they banged into my back, and I had HCl all over my shirt, which was not nice.
Did you go in the shower?
I didn't go in the shower, no.
Did it burn you?
I just took off my shirt, not in the middle of class. That would have been weird.
Why not?
I went into the back room, changed shirts. But my shirt then had a hole in it.
Oh, it did? Oh my god.
Yeah, well, it had a little hole. Okay, so I now have all of the chemicals in there. And my goggles are steaming up. That's right, so I did the goggle dance. I follow along now with my flowchart, okay? I follow along with my flowchart. The first thing says add CaCl2. Here's my CaCl2 right here in the reagent bottle, and I'm going to go across this first row here, right in each one of these wells, and I'm going to see what happens. So I have, boom. Did you see that? No. Did you see it? No.
Yeah.
Right there. I need to be more on top of this thing.
You're like a head camera.
Yeah, I know. That one's nothing, that one's nothing, and that one's nothing. You can see that immediately this first one here gave a white precipitate. All right, that is a positive result. None of the other ones did. And therefore, in my flowchart, I would say test tube C1 is PbNO32. And so you can write that down in your flowchart now. Test tube C1 is PbNO32. Next, I'm going to add MgSO4. okay? Because that is now Abby's second test, MGSO4. And so I want you to look here on the screen. The lettering right now and the numbering is not important. I'm going to go along this row here. I'm not going to go in the row that I just added chemicals to. All right, that is now contaminated with 2 different sets of chemicals. I want to go through this second row. This only has the unknown chemicals. I don't even need to add it to this first row. That's a label. That's not actually a precipitate that just fell in there. I don't even need to add it to this one because I know what this is. And so I'm going to place it into my other wells here. I'm not seeing any reaction there. I'm not seeing any reaction there. Ooh, and I'm not seeing any reaction there. Oh, it forms in over a minute. Oh, that's the slow one. All right, well, I'll come back to that in just a minute then. But you see, that's the frustration of choosing that one that forms slowly. You have to wait. The last one is adding magnesium metal. And does it fizz H2 gas? And again, I've identified this first column here, and so I don't need to add it to that first one. So if I place it in this well here, can you hear that? Can you see it on the screen? That one's going nuts. That one is HCl. Okay? I can add the magnesium metal to the other ones, but I don't really need to. But I will, just because I'm feeling safe. Better safe than sorry. That one doesn't have a lot of chemical in there. But it is not doing anything. So, I've identified now chemical C2 as HCl. So, wherever you have test tube blank is HCl, the answer is C2. So, I'm still waiting for this magnesium sulfate test. So far, I have not been particularly successful with this magnesium sulfate test. Okay, I've not been particularly successful with this magnesium sulfate test. And what I'm trying to do is I'm trying to now tell the difference between calcium hydroxide, because that's the only one that I haven't identified, and sucrose. Calcium hydroxide and sucrose. How can I test the difference between calcium hydroxide and sucrose? Yep. I could do a conductivity meter test. The problem is I've just contaminated both wells. And so now everything has ionic compounds in it. I could go and get a new spot plate, and I could do it again. That would be absolutely fine. How else could I do it, Jeffrey? Yeah, what would that do? Right, it'll turn it pink. And it'll only turn the base pink. I haven't added a base to any of these other wells. I'm living on the edge here, okay? I shouldn't be doing this. I shouldn't be saying or suggesting that you do this now in the same well. So please take note. I should not be suggesting that you do this test in the same well. But I'm going to because I believe that I haven't added any other hydroxide ions. So the 2 that I'm trying to tell between are this row here and this row here. And whichever one turns pink is going to be the calcium hydroxide. Let's try this one. That one looks pink. That one does not.
That would be awkward.
So, again, hopefully you can see the pretty pink. Now, in the back of my mind, I could kind of see a slight cloudiness to that well. So I was suspicious about that in the first place. I thought that was the precipitate that was forming slowly. Turns out that is the calcium hydroxide, which also would back up the fact that that was the one that was forming really slowly.
Is that C4?
And so that is C4. C4 is CaOH2.
And then the other one's...
And therefore, by process of elimination, the other one is sucrose.
The computer just won.
Wait, test tube C4 is what? Ooh,
Test tube C4 is CaOH2. At this point now, I'm all done. And so I'm going to go and throw away my chemicals, right? No, don't do it. Don't throw away the chemicals. Go and type it into the computer and make sure you're right. Then, if you're not right, you can come back and you still have full sets of test tubes ready to go. You still have your results table right here. This spot well is a results table. You have your dependent variables and your independent variables lined up correctly, okay? And you can check the individual results. Harry?
Do you put the process into the computer or just the results?
No, you just put the results. It's going to say enter the test tube number that you believe is lead nitrate, and you'll put in C1. Then it'll say, okay, which one's calcium hydroxide? You'll say C4. So that's that. Does anybody think that they have a plan B? A flowchart plan B?
Can you check something for me? 'Cause there's something that...
Yes, you need to write the chemical formulas for the 2 precipitates that form.
Oh, really?
Yes, so that's the thing.
Well, they're like not in the bottom.
So that's the thing. Oh, sorry. The only way to split these two groups up, or this group up, is to look for a precipitate. And it's a white precipitate. But you're going to find two different chemical formulas. And we need to see both of those chemical formulas in the diamond. Does a white blank or blank precipitate form? Done. Okay, you don't know the difference between the two, which is why you've split it off now. And you have to ask another question. But you know that both precipitates are white. So here, Jeffrey added sodium bicarbonate, NaHCO3, and checked to see whether or not calcium hydroxide or lead nitrate formed a white precipitate. And the two precipitates were calcium bicarbonate and lead bicarbonate. So that splits off the calciums and the leads. Jeffrey then added sodium hydroxide to pull out lead hydroxide to identify the lead, and therefore identify the calcium. And then on the left-hand side, then he had magnesium metal to divide the HCl and sucrose, which was, again, a similar test to what I just showed you on the screen. Okay? There are many ways to skin these cats, all right? There's always new tests that you can do. You noticed in that one that I just did on the screen that something went wrong. I couldn't wait. I didn't want to wait. I was impatient. The concentrations were too low. Whatever it was, I tried to work out another test that I could do. But I was very careful about which test I did. I didn't add the conductivity meter test. Oh. I didn't add the conductivity meter test because, well, I knew that I'd contaminated those wells. Now, if I'd gone away and got a new spot plate, it would have been fine. But I was lazy. Okay? In this case, I knew that no other bases had been added, and so I could do a phenolphthalein test. Yeah?
If you change something that you're doing, do you have to go back and edit your flowchart?
I recommend you edit your flowchart, but at the same time, no. Like in that instance, I had a choice of 50-50 chance here.
And then you could always redo the whole thing.
And so I could always go back and just identify those, because I had very positive tests for those other two test tubes. So I could have, in theory, pulled those test tubes aside and put them into my little beaker and put them away saying, check, done. Now I just have these two.
Right.
And so then it's kind of up to you what you do. It's always good to document your process just so that you keep your head straight, because when things go wrong, that's when your head goes blurry and you're like, wait, what did I add here? And wait, what did I do? And oh my gosh, what have I contaminated? And so it's a good idea to document it, but at the same time, I'm not rechecking your flowchart.
Okay.
Okay?